I'm Yangjun, and I'm a PhD student at the University of Toronto, and I'm a visiting student at Stanford University with Tatsu. And so here, in this paper, we are trying to make scaling laws more accessible and can we do scaling law analysis in a very low-cost ways. So we are interested in scaling analysis, which people have shown that we can do a lot of model capability predictions or resource allocations. But the key thing here is that it's very expensive because we have to train a lot of models at different scales to do reliable scaling predictions. And it also requires us to train models in a unified way, by carefully controlling the training recipes. So the key contribution of this paper is called observational scaling, where we can do scaling analysis without training any models, but just utilizing a large set of existing models, which enables us to do a very high resolution and a reliable scaling analysis. So the key motivation here is that there are a lot of existing models on Hugging Face. Can we actually just utilize them to do a scaling analysis? And the key barrier here is that models trained differently from different model families demonstrate very different training efficiencies, and we cannot just unify them together. And the key idea or observation is that for the language model capabilities, there exists a low-dimensional space that we can extract from existing benchmarks that capture most of the variance of language model capabilities. So for example, we've did an analysis where we've collected a bunch of existing models and their benchmark performance, where we did a simple PCA analysis and found that only 3 PCs capture most of the variance on these benchmarks, which means that the model capabilities are very low dimensional. So utilizing this fact, the more interesting piece is that the complex downstream capabilities of models' agentic capabilities or emergent capabilities also live in this low dimensional space. And we can fit a reliable scaling laws utilizing all the public models from these PC measures to the downstream performance and do a very interesting scaling analysis. And so here are the results, where we've shown that we can predict what's so-called the emergent capabilities that people are caring a lot about. We've utilized a model that are weaker than Llama 2.7 billion to predict the performance at the level of Llama 400 billion. And we can also predict models' performance as end agents, where we are using models that are weaker than ChatGPT to predict the performance of GPT-4 level of models. And we can also analyze the impact of post-training techniques to understand the scaling of different techniques like train of thought or self-consistency, where we fit scaling curves with and without the methods being applied and compare their scalings. And we found that different methods demonstrate very different scaling properties, and train of thought is very scalable. Okay, that's for the overview, and thank you for your listening.